Before we get started, I want to review our appropriate PPE that you need for doing this task. It's important to have a good pair of work gloves that don't limit your dexterity, an approved pair of safety glasses, and a 4-gas analyzer that's been calibrated. So today we're using a aluminized Tedlar bag, and they make non-aluminized bags as well, but for H2S it's very important to use an aluminized bag, so that way the H2S doesn't get absorbed or dissipate through the actual bag itself. You don't want to get a false low reading from the lab. So make sure that you have the right bag, and it's also important to contact the lab and let them know that you're going to be taking a sample and that you need a quick turnaround time on it so that we can get the gas analyzed as quick as possible. Ideally, it would be within 24 hours. So if you have the ability to drive the sample to the lab, that's the way to do it. So before you get started and actually take the sample, it's important to make sure you have all the equipment you need. So you have your bag. On the bag, you'll notice that there's a stem on the valve, and on this one you can see there's a little red piece that we put on there so that it would fit well into our 1/4-inch tubing. It's important that the tubing fits tight to this stem on the valve. So if you don't have some kind of connector, you can use electrical tape to wrap the stem to be sure that the tubing's tight. We set up a piece of 1/4-inch tubing. Let me pull this off. We set up a piece of 1/4-inch tubing with a small T on the end, and we leave the bottom portion of the T open, and we put a piece of tubing no more than 2 inches long on the end. This is what will eventually hook to our bag. So the reason we do this is so when you run gas through the line, you can purge it through the bottom of the T, and you don't get any contaminants into your sample, and you get rid of all your air. If you're sampling a device or a source that's under positive pressure, you don't need to use the gem. If you can just hook this directly to the source, purge the gas through the line using the bottom portion of the T, and hooking your bag up to this side. But in this case, our source is under vacuum, so I'm going to demonstrate how to use the gem to take the sample, and you would follow essentially the same steps without the gem to get the sample if your source is under positive pressure. So when you're using the gem, it's essentially you remove your carbon filter. You can't use a carbon filter because the carbon will absorb your H2S and you'll get a false low reading. You also want to leave your water trap though, because if there's any liquids, you don't want to pull that into the gem and damage the unit. So I set this up with a water trap, no carbon filter, and then on the opposite side of the gem, there's an exhaust port. You can hook a piece of tubing to that exhaust port and use the gem as a pump to fill your bag or container, whatever you're going to store your sample in. So I'm going to hook that to my exhaust port. I'm going to go ahead and attach my tubing to the source that I want to sample, and I'm going to start my pump. I want to keep this hose dangling down for a minute to let the H2S purge through the line. So I purge the tubing, the gem, and the other tubing on the other side of the gem. So we're going to let that purge for a second, and then you're going to grab your bag that you're using for sampling. They all have a valve up on the top that you can open or close. When you get them, that valve is always going to be closed. This one shows you which way to open the valve to allow the gas in. So after I've purged my lines, I want to make sure that I'm keeping the open portion of this T pointed away from me or down. You don't want that gas blowing in your face. And go ahead and attach it to the other piece to the bag, the stem of the valve. So when I did that, now gas is being forced out the bottom of the T. I'm going to go ahead and slowly open the valve on the bag and put my finger over that open portion of the T. This is going to force all the gas into the bag and let it slowly pressurize. So when you're doing these samples, it's important to take the sample as close to atmospheric pressure as possible. And so you don't want to, that's why we're using a bag instead. You don't want to pull directly off of your source. It's better to put it in some kind of container. When you fill the bag, you don't ever want to fill it more than 80% full. It's important that the bag is not too pressurized. It could explode and leak the gas during transit. The other important thing is to write the sample ID or the name of the device that you're pulling the sample from on the bag. Use a Sharpie so you don't puncture the bag, and put the date and the time, temperature if needed, any info you can on the bag so you don't lose track of your sample. You also want to keep it out of the direct sun for long periods of time. So after you take the sample, go ahead and put it in a box or put it in the cab of the truck so it's not exposed to the sun. So as you can see, this fills up pretty quick with the gem. I'm going to let it go just a second longer, and that should give us plenty of gas for our sample. So when I'm done, I go ahead and, when it's full enough, go ahead and close the valve and remove your finger from the bottom of the T. It'll let the gas diverge out. You can go ahead and shut off your pump on your gem so no more gas is being pushed through, and remove the tubing. So I always double check to make sure that valve is nice and tight, the bag's closed, and should be ready to be shipped to the lab. Before we get started, I want to review our appropriate PPE that you need for doing this task. It's important to have a good pair of work gloves that don't limit your dexterity, an approved pair of safety glasses, and a 4-gas analyzer that's been calibrated. Alright, so now that we've collected our gas sample into a Tedlar bag, we've shown how to do that. You can use that same procedure, but instead of sending the bag to the lab, you can use it as a point to pull gas off to use a gas detector tube to measure H2S, which a lot of times is more convenient and quicker than having to wait a couple days on the lab. So you would fill the bag the same way that we just reviewed, and then you would set up your gas detector tube and pump to be able to do the job. So it's important when you do this that you have the same pump and same tubes from the same company. So the reason I point that out is I have an MSA pump and I have a Draeger pump, and they both do the job and work the same way, but they have different size tubes. So if you look at the end, this little rubber fitting that the tube attaches to is different sizes, and so if you try to use an MSA tube on a Draeger pump, it won't fit, and vice versa. So make sure that the tubes you're using fit well into the pump that you're using. It's also nice when you're setting up to take the Draeger tube read or a gas detector tube read, that you make sure you have a good scale for the source that you're sampling. So this particular one is between 100 and 2,000. That's a nice range. I also like to have a set typically that goes from 1 to 200. So that way if you have a little bit lower H2S, you can see what it is, but you also have the upper end. So you can buy these tubes in all kinds of different ranges. Before you take any sample, there's a few things to look at on the tube to make sure you know what you're doing. So there's an N equals number printed directly onto the tube. And that number tells you how many strokes you need to pull with the pump. So on this particular tube, it's N equals 1. So I only need to make 1 stroke with my pump. If I had dual scales on this tube, it would most likely be, there'd be a scale for N equals 1 and a scale for N equals 10, which would mean I'd need to do 10 pumps if I did not get a reading with 1 pump. So definitely look at your scales and look at the N equals number to make sure you know what you're doing before you get it all set up. The second thing is there's always an arrow that's pointing in this particular direction. You want to make sure that that arrow is always pointed towards your pump or to you, and it indicates the flow of gas into the tube. So a lot of the pumps come with a tip breaker on the bottom. It's a little metal port you can put the tip of the tube into and break them off. Some come with a little canister on the side, and these are actually really nice because it collects all the glass shards for you in the canister. So when you do this, be careful. It's glass, it's fragile, and it's very sharp. So you don't need to use a lot of pressure, but insert the tip of the tube into the tip breaker, break it off on both sides. Now you have a sharp end, so make sure you're wearing your gloves. Be careful. Then what you want to do is on the bag that you're sampling from, you need to connect a small piece of tubing so that you can draw the sample from the bag. So in this particular case, I've pre-cut a piece of tubing no more than 2 inches long. I'm going to use to hook to the actual bag and then to the tube that I'm taking the sample with. So I go ahead and push that into the end of the tube, and then I'm going to use the same little connector I used a few minutes ago to hook it to the bag. If you don't have a connector, you can always use a piece of electrical tape or wrap the stem of the valve on the bag with a couple rounds of electrical tape to be sure that it's tight. So in this instance, I'll go ahead and put this little connector we made and attach the other end of the tubing to the bag. So this is how it should look when it's set up. Now you can go ahead and attach the broken end of the tube directly to your pump. Push it in gently. You don't need to be too aggressive with it, but make sure it has a nice tight seal. On the front of the pump, there's going to be some kind of stroke indicator. On this one, it's a small glass bubble, and it shows white right now. When I compress this pump, it's going to change to a different color. So the reason that's important is when you compress it, you do not want to record the level of H2S off of the sample until this indicator turns back to white or whatever color it is in normal state. So once you have it all set up, and I know that I only need 1 pump, go ahead and open up the valve on the bag. Now completely compress the pump all the way till it bottoms out, and then release it. It will manually pull the sample through, so it's not going to give you tons of pressure back onto your hands. Watch your stroke indicator to know when it's completed a full stroke. So it just changed back to the white for me. So I know that this well has just over 400 ppm of hydrogen sulfide. So I like to record that right away, write down in your log the date, the time, the location of your sample, and the volume of hydrogen sulfide that you read on your gas detector tube. Then you can take the tube out. Be careful, you don't want to break anything. Close your valve back off on your bag so no more gas is coming out, and properly dispose of your gas detector tube. Before we get started, I want to review our appropriate PPE that you need for doing this task. It's important to have a good pair of work gloves that don't limit your dexterity, an approved pair of safety glasses, and a 4-gas analyzer that's been calibrated. So now I want to go ahead and show how to use a canister to take an H2S sample using a gas detector tube. Dave Harrison came up with this idea, and it's nice because it saves us from having to reuse Tedlar bags and the expense of that. So the only thing that's going to be really important when we use this is that you purge it good each time, so that way we don't get contaminated samples. So just like we've talked about before, if the source that you're going to be testing from is under positive pressure, you can go ahead and hook your lines directly to it. So you would hook a piece of tubing directly to this port, hook it up to the source that you're being sampling, and open up the valve on the back to allow the gas to purge through. Once it purged through, you would close this valve, let a little bit of gas build up into this canister, and then remove the tubing from this side, and now your sample is captured. Then you could take the gas detector read from this. But in this instance, I'm going to try to do it with the GIM because our source that we're sampling is under vacuum. So once again, it's important to make sure that you remove the carbon filter from your tubing that you're using to take the sample. The carbon filters will strip out your H2S. We do want to leave our water trap so we don't get any water or contaminants into the GIM. And then you're going to hook a piece of tubing to the exhaust port of the GIM and allow the GIM to pressurize this container. So the first thing I'm going to do is on the piece of tubing that I'm using on the exhaust side, I'm going to go ahead and remove the small T that we used earlier and attach a quick connect fitting from the quick connect fitting from that'll allow us to hook directly into the canister. So once you have your tubing all set up, jam up to the port that you're wanting to sample. You'll take the other end, your exhaust line, hook it up to the quick connect fitting on the container that we made. All this container is a 2-inch end cap with a flat end on the top. HDPE, one fuse in the middle, welded them together. Dave tapped the ends so that he could screw in the fittings. So really simple to connect, nice and easy to throw into place. So connect the tubing, open the valve on the other end so we can let the gas purge through. Make sure this is pointing away from you. You don't want the gas blowing in your face. Go ahead and start your pump. You want to let your pump run for a minute so that way it purges the entire tubing, the gem, the tubing on the exhaust side, and this new canister. If you're using the canister over and over, it's important to let it purge really well so that way you don't get any contaminants. Remember too, when you're taking a gas detector tube reading, you only need a very small volume of gas, so you don't need to store a bunch of gas in here or let a bunch of gas pressurize up. Just a few seconds will suffice. So we've let this purge pretty good. Once you've let it purge, go ahead and close the valve on the outlet side. You can see that the pump, I don't know if you can hear, but the pump's working a little bit harder, trying to pressurize up this container, pushing that gas in. Once it does that, I'm going to go ahead and shut the pump off so I stop pulling gas into it, and I remove the quick connect fitting. So now my sample's captured. So you can hang your gem back up, remove the hoses from your shores, and then you need to have a way to attach your gas detector tube. So what we did was, I'll just go ahead and take this piece off. I'll take the quick connect fitting off of one of the ends of the tubing we just used, and I have a less than 2-inch long piece of tubing that I pre-cut for the gas detector tube. Go ahead and hook that up. Before you attach this to the canister that you're going to be using, get your gas detector tube set up and ready to take the sample. So in this case, we're going to be using a Drager tube with a Drager tube with a Drager pump. And before you do it, make sure that the tubes that you're using match the pump that you're going to be using. So I have an MSA pump, and the MSA pump has a little bit different size tubes than the Drager pump. So it's important that they match so that you get a nice tight seal when you attach your tube to your pump. So in this instance, we're going to use the Drager pump and the actual Drager tube. When you look at your tubes, make sure that you check what the scale is before you take your sample. So if you think that this collector may be 400 or 500 ppm of H2S, then make sure that the scale you're using encompasses that. It's nice to have a couple of different sets on hand. I like to have one that ranges from 1 to 200 parts per million, and also one that ranges from 200 to 2,000 parts per million. So that way you can cover all your bases. This particular tube we're using today is from 100 to 2,000 ppm. Make sure that you look at the N equals number located on the tube. That tells you how many pumps you need to pump with your actual pump. And so on some of them you will have a scale that says N equals 10. You need to use 10 strokes. This one is N equals 1, so 1 stroke. Also look to see which way the arrow is pointing. The arrow on this should always be pointing towards your pump. That way you know which way you're pulling the gas through the tube towards the pump. So I go ahead and you can install that, push it into the fitting on your pump. You don't have to push hard, just push it in gently, make sure it fits nice and tight. Get our canister that we have set up with the tubing that we made a little bit earlier. Go ahead and take the tubing, attach it to your detector tube with a nice tight seal, and then go ahead and gently push the connectors together so that way you can get your sample. So now we're all connected. I can go ahead and compress my pump and let off of it. Look at your indicator on the pump to make sure that your sample stroke is being done correctly. It's initially kind of white, and when you compress the pump it changes to a different color. So you're going to want to wait till when you compress it and it changes that different color, wait to record your reading until it goes back to the original white or whatever color it is in normal state. So we're taking our sample. It's taking a second. Once it gets its full stroke, we'll be able to see what that color is. Okay, so the indicator just changed back to white, which shows us that our pump is strokes completed. So now you can go ahead and disconnect it from the piece of canister or tubing that you're using. Take the gas detector tube off of the pump. I like to record right away what level of H2S that we're seeing. So write it down in a log with your time, date, and the location of the sample, and then properly dispose of your tubes.